Okay, here we go with solving equations involving common and natural logarithms. I think I'm about to lose my voice, so hopefully I can make it through this in the next video. You notice that the variable is actually in the exponent spot. So in the past videos we've talked about how if I see that, I really want to try to get both bases to match. So I typically try to manipulate the side that doesn't have the base, it doesn't actually have a base, and rewrite the problem so that it has a base that matches. And then of course we can use the one-to-one property of exponents to determine the solution. In this problem here, we're not going to be able to do that. The reason is that I'm never going to be able to get a 12 and a 60 to be rewritten as a matching base. So when we see that situation, we're going to have to resort to another method. So what I'm going to do is show you a property. I'm going to erase this right here. And this property looks like this. If I have some log with a particular base, doesn't matter what, and then there's an argument, and that the argument actually has a power. Okay, in other words, the whole log is raised to a power. I'm actually allowed to bring the power, bring it down on the baseline so that it's not a power, and put it in front of the log, okay, as a factor. Okay, and that's just because logs are exponents, and so I'm allowed to take the power that's around the log and just multiply it a certain number of times, because that would be adding exponents, and that's what we do when we take something to a power, we add the exponents. So let's go ahead and take a look at how we could use this property. What I'm going to do is I'm going to actually take the log of both sides. So I'm slipping in a little bitty word log in front of both sides of the equation. Now if you notice, what I have now is this setup right here on the left side. Of course the base is a common log, and the base is 10. So the b here would be a 10, but I don't have to write it. So it looks like what I'm allowed to do then is to take this left-hand side, okay, and rewrite it where the x is actually on the baseline, sitting in front of log 12. Now I'm just going to copy the right-hand side because we haven't done really anything with an exponent there. Okay? So now this is really great, because now all we have to do, all we have to do is divide both sides by log of 12. Alright, so we get x is log of 60 over log of 12. Let's take a look at the calculator. Log of 60 divided by the log of 12. Alright, let's see what we get. 1 point, and it says round to 4 digits, 1.6477. Alright, 1.6477. Now let's take the original problem and let's just see if it really does equal, if this really does equal 60, 1.6477. Okay, I'm putting that in the x spot. So let's take a look. 12 to the power of 1.6477. And let's see. Hey, very good. It checks. 60 roughly equals 60. We're good. Let's take a look at one more. Okay, and on this one, we have an e showing, and so first of all I need to understand that this is the exponent, not the e. E is a number, kind of like, well, it's irrational, like pi is irrational, but e is actually about 2.71. There goes my voice, I think. Anyway, the reason that we're going to, because it has an e, we're not going to be able to use common logs. We're going to have to use a natural log. Okay, so no common log, we're going to have to use natural log, because I see an E. So first of all, we have to clean off in front of the base. Whenever you're about to take the log of both sides, you must clean off in front of the base. All right, here we go. Now the base is clean. Here's the base here. There's no way I'll ever get E to be the same as 7/3, so I must use logarithms. Natural log, natural log. This allows me to bring the exponent around to the front. Oops. Oops, pardon me. That's times natural log of E, and then I get natural log of 7/3 on the right. If you take a look at what natural log of E is on the calculator, we see that it's the number 1. So I'm going to replace this with a 1. So now this is what I have. I have 0.4t is equal to the natural log of 7/3. Alright, and I'm ready to go ahead and divide by 0.4, and I get that t is equal to, let's go to the calculator, natural log of 7 divided by 3, enter, divided by 0.4. Oops. Okay, something looks fishy. Let me try that again. Clear. I didn't use the natural log. Natural log of 7 divided by 3, enter, okay, divided by 0.4. There it goes. 2.1182. Let's take a look. 2.1182. Okay, and we're going to call that roughly. All right, hope this was helpful. Thanks for watching.